Question number 1. What about the app Occlusion Analyzer? Can you show us how to use it or your patient's cases in the future webinar?
Let's go into App Box in the Medit link and click on Medit Occlusion Analyzer. It has the following description. Medit Occlusion Analyzer is an app developed to help you streamline the routine task of analyzing the occlusions. It can automatically analyze the occlusal interference between the maxilla and mandible and display the results through a color map. With the provided tools, you can also study the occlusal relationship more thoroughly and, if needed, realign data acquired from Medit scan software. Major features: automatic occlusion analysis, analysis through section view, realignment to bite scan, replay of the mandibular movement. Let's check out a sample case. When you run the app, it starts with the automatic occlusion analysis screen. It will automatically show you the area of occlusion interference. You can also analyze a cross-section of that area. Unlike the traditional Medit interface, this app has menu buttons on the left side. It's easy to miss if you are a first-time user. There are features to realign the bite and modify the mesh. There is also a function to play back the mandibular movement recording. It is very convenient to be able to run these functions without going into the scanning software.
Number 2. Do you think the watermark on the tip mirror affects the data accuracy?
Medit said that it doesn't affect the scan accuracy. Sometimes watermark can appear on the tip mirror even if users use autoclave program recommended by Medit. But as long as the autoclaving is done within the recommended frequency, it should not affect accuracy. In a case when users can recognize the clear watermark through the live view, it will affect the scan data accuracy.
Number 3. Wouldn't Emacs be more aesthetic than 3D printing?
There is no doubt that ceramic is a very aesthetic and well-proven material, but its main disadvantage is that it is very difficult to process below 0.5 mm thickness, so you have to remove the structure to get enough thickness for the prosthesis. 3D printing is capable of printing as thin as 0.1 mm thick, so I wanted to show how it can be used by unprepping tools for laminate restoration.
Number 4. The scan data seems less sharp than the impression. If there is a slight gap between teeth, the scanner seems unable to acquire this area. Can you suggest anything?
Right, if you want to represent a sharp area, you can use the high resolution mode to improve it somewhat. If it's still not enough, you can simply acquire an impression of the corresponding area and make adjustments using the impression mode.
Number 5. I don't believe 3D printing is accurate. Since even simple model printing isn't that accurate, how can you be certain? And another question is, what kind of work do you do with 3D printers? And how was it? Your opinion or experience with those works?
Errors in 3D printing can occur for a number of reasons. Polymerization, shrinkage of the resin, and the jelly effect that we talked about last time are the main ones. To reduce these problems, using low viscosity resin will be a big help, and using well-validated profiles is necessary. Through this process, you can obtain results of the quality that you have seen in my clinical cases. In the near future, I will share how to modify the profile to improve the output result. Also, the Medit app will include recommended printers and settings for your prosthetic type.